Hi, I'm Tomer Tan from Dell Technologies. In this demonstration video, I'm going to walk you through the configuration of the Dell PowerStore virtual volumes with RedHat OpenShift and VMware Cloud Native Storage driver and the deployment of a Kubernetes application that can leverage these capabilities for Kubernetes persistent volumes. With OpenShift 4.10, customers running OpenShift on top of VMware vSphere can now use the built-in VMware CSI driver, as known as Cloud Native Storage, to consume storage for their persistent volumes. For the purpose of this demo, I deployed an OpenShift cluster running on top of VMware vSphere 7 Update 3. By navigating to PowerStore Manager and clicking on the Storage Containers tab, we can see the default vVols data store. These OpenShift nodes are running on this vVols data store. If we navigate to the vSphere client, we can see the OpenShift virtual machines and the vVols data store, which is mounted on each of the E6A hosts in this cluster. In order to start creating persistent volumes on this data store, we need to create an SPBM policy and attach it to our vVols data store. As you can see, I created an SPBM policy called PowerStore vVols and added my PowerStore vVols data store to it. Next, we need to create a storage class in OpenShift. We navigate to the storage classes page in OpenShift user interface and then click Create. Then, we switch to the YAML edit mode. We give it a name and set a provisioner to VMware CSI driver and the storage policy name to the PowerStore vVols SPBM policy I've just created in vSphere. This means that each persistent volume claim from this storage class will be created as a virtual volume on PowerStore using the VMware CNS driver. At this stage, we are ready to provision a new stateful application. I navigate to the Installed Operators tab and select the CockroachDB operator, which I installed in advance. Then, I click on Create Instance and set the storage class to PowerStore vVols, and then click Create. We can see that three 100 GB persistent volumes have been created from the PowerStore vVols storage class and attached to the three CockroachDB pods, which are now up and running. By navigating back to the vSphere client, we can see all the tasks that were run automatically by the VMware CNS driver when I initiated the pod creation, such as creating the vVols on PowerStore, mapping them to the E6A hosts, and mounting them to the virtual machines and the pods themselves. One of the main advantages of running OpenShift on top of vSphere is the insight we receive via CNS. Rather than having keep switching between arrays views and data store context views, we can view all the information relevant to the persistent volumes consuming vSphere storage in one place. Under the Storage Containers view, we can see very useful information about the persistent volumes managed by the CNS driver. By navigating to PowerStore Manager and clicking on the vVols tab, we can see the newly created virtual volumes, which are VMware first-class disks. FCDs can be created, snapshotted, resized, etc., just like a virtual disk, but without a VM to own it. This is exactly what Kubernetes persistent volume claim is. Now, let's say that we need to scale up our application pods. With OpenShift and the CNS driver, it is as simple as a click of a button, or a single kubectl command, depends on what type of person you are. If we go to the vSphere client, we can see the CNS tasks running in the background, and within a few seconds, the number of pods and persistent volumes has doubled. Dell PowerStore vVols integration is a key component of this solution, as it offers full flexibility and granularity that may be required by your containerized application. You can define multiple SPBM storage profiles, which can be assigned to a different storage classes within OpenShift and any other Kubernetes distribution to really fit your needs. I really hope you find this demo useful and thank you very much for watching.